So hello everyone, welcome back to this lecture series on the topics of numerical methods. So in the last lecture we discussed about the Gauss-Seidel method, which is basically used to find the approximate solution of the system of linear equation of the type Ax equal to b. Okay. Now in this lecture we are going to discuss about the finite difference operators and their relations, which is very important in the interpolation technique and numerical differentiation. So let us start with a very basic idea. So what is finite difference operator? Okay. So in calculus we use derivatives to measure the changes, okay? But when the data size is given at discrete points, okay, instead of continuous function, so in that case derivatives are not available directly, okay? So if we have discrete data points, then in that case we will use the difference operator to calculate the approximate changes, okay? So the most commonly used operators are forward difference operators, backward difference operator, shift operators, and the central difference operators. So what is forward difference operator? So basically this operator is defined by the delta, and it is defined as delta f of x, okay? So if we operate this operator to any fx, then you will get f of x plus h minus f of x, okay? So what is f of x plus h here? So suppose let us define a discrete data set, okay? So suppose we have data set like x0, x1, x2, x3, x4, and their functional values f of x0, f of x1, f of x2, f of x3, and f of x4, okay? So this is your x and this is your fx. So f of x is the function value at current point, okay, and f of x plus h is the function value at next point, okay? Means if we choose the data x0, okay, and if we choose delta f of x0 and we operate the forward difference operator at this point, then we will get f of x0 plus h minus f of x0, okay? So what is f of x0 plus h? The function value at next data point, okay? So f of x0 plus h is f of x1 and minus f of x0. So what is h here? H is distance between two data points, okay? So difference between x1 minus x0 is h. Similarly, x2 minus x1 is h, x3 minus x2 is h, and x4 minus x3 is again h, okay? So in general we can write xi equal to x0 plus ih, where I is vary from 1 to 4, okay? So basically the forward difference operator measures the changes in forward direction, okay? If we apply the forward difference operator to this point, then you will get f of x2 minus f of x1, okay? So this measures, you can write this measures changes in forward direction, okay? So second one is backward difference operator, and it is defined by the nebula, okay? And if we operate this operator to any fx, then you will get f of x minus f of x plus x minus h, okay? So this is x and x minus h. Okay, so can we calculate the backward difference operator at x naught at this point? So the answer is no, because this backward operator needs the value at previous point. Okay, so x minus h, the function value at f of x minus h. So we cannot use the backward difference operator at this point. Okay, but at this point we can use backward difference operator. So if we calculate, suppose delta f of x1, then we will get f of x1 minus f of x1 minus h. Okay, so this is equal to f of x1 minus f of x1 minus h is x naught. So f of x naught. Okay, so this backward difference operator measures the changes in backward direction. Okay, now third operator is central difference operator. Okay, and if we apply this operator to any function fx, then we will get f of x plus h divided by 2 minus f of x minus h divided by 2. Okay, so basically we can say this operator is more symmetric and give the better accuracy. And fourth one is the most important operator, it's called shift operator. Okay, so it is denoted by capital E. Now if we apply the shift operator to any function fx, so if we apply the shift operator to a function fx, then we will get f of x plus h. Okay, so this operator simply shifts the function in forward direction by one step. Okay, similarly we can write, if we apply the shift operator again, means e to fx, then we will get e of f of x plus h. What is e of x plus h? This is equal to f of x plus 2h. Okay, and suppose if I want to calculate e to the power half f of x, so what it means, this operator shift the function to f of x plus h by 2. Okay, so basically this operator shifts the function forward by one step, half step or 2 step. So these all are operators. Okay, now coming to the relation between operators. Okay, so the interesting point is how these operators are related to each other. So these are some relations defined between the operators, okay, which are very important. Now we will prove one by one. Okay, so coming to the next point. So first relation is relation between shift and forward difference operator. Okay, so it is defined by E equal to delta plus 1, means relation between shift operator and forward difference operator. Okay, so we can prove this relation. Okay, so suppose if we apply this operator to any function f of x, so we will get delta f of x plus f of x. Okay, which is equal to, if we apply the forward difference operator to any point fx, any function fx, then we will get f of x plus h, okay, minus f of x plus f of x. So here fx and fx cancel, we have f of x plus h. Okay, so what is the f of x plus h? F of x plus is equal to e to the power e of f of x. Okay, so if you compare these two quantities, then you will get e equal to delta plus 1. Okay, so second relation is the relation between the backward difference and shift operators, and it is defined by E inverse equal to 1 minus nabla. Okay, now we can prove these relations. If we apply this operator 1 minus delta to a function fx, then we will get fx minus backward difference operator f of x. Okay, so this is f of x minus, so backward difference, if we apply this operator to any function fx, we will get f of x minus f of x minus h. Okay, and here fx is cancelled, we will get simply we will get f of x minus h, which is equal to shift operator inverse f of x. Okay, so if you compare these two sides, you will get E inverse equal to 1 minus delta. Okay, now your third relation is central difference relation. Okay, so this relation is defined between the shift operator and central difference operator. So what is the relation here? The central difference operator is equal to e to the power half minus e to the power minus half. Okay, so we know that e to the power half f of x equal to f of x plus h by 2. Okay, similarly we can calculate e to the power minus half. Okay, so if we apply, if you calculate e to the power minus half f of x, you will get f of x minus h by 2. Okay, so if we apply this operator e to the power half minus e to the power minus half to any function fx, then you will get e to the power half f of x minus e to the power half f of x minus. So e to the power half f of x equal to f of x plus h by 2 minus e to the power minus half fx equal to f of x minus h by 2. Okay, so f of x, okay, so we can write this is basically the central difference operator delta f of x. Okay, if you compare both sides, then you will get delta equal to e to the power half minus e to the power minus half. Okay, now third relation 4 is important, very important identity relation. Okay, and this relation is connect the forward and backward difference operator. Okay, so the backward difference operator into shift operator equal to the shift operator into backward difference operator equal to forward difference operator. Okay, so we can prove this operators also. So suppose if we apply this operator to any function f of x, then we will get this is equal to nabla into e f of x. Okay, so what is shift operator f of x? It is f of x plus h. Okay, so this is equal to nabla into f of x plus h. Now if we operate the backward difference at the point f of x plus h, you will get f of x plus h minus f of x. so which is equal to the forward difference operator f of x. Now if you compare both sides, you will get nabla E equal to delta. Okay, so basically this relation connects the forward and backward difference operators. Now coming to the forward difference table. Okay, here I am going to construct the forward difference table for a given data set. Suppose if we have data set x and fx, suppose we have x equal to x0, x1, x2, x3, x4. This is your f of x0, f of x1, f of x2, f of x3, f of x4. Okay, and distance between these 2 points are equal, which is equal to h. So suppose x0 for xi equal to x0 plus ih. Okay, so here the distance between each data point is h. Okay, so to construct the forward difference table, first we will write these data points into the column form. Suppose, so let this is your x and this is your fx. So x is given x0, x1, x2, x3, x4, and we have total, sorry, not x5. So first we take only 5 data points. Okay, so what is f of, this is f of x0, f of x1, f of x2, f of x3, f of x4, and okay, so how to calculate the forward difference table? So first, if we have data points, we can calculate the first forward difference delta f of x. Okay, so if we apply the first forward difference delta f of x0 at point x0, then we will get f of x0 plus h minus f of x0, which is equal to f of x1 minus f of x0. Okay, so if we apply the first forward difference at point f of x0, then we will get the f of x1 minus x0. Okay, so means difference between these 2 points, so we can write in the middle. Okay, so first forward difference at f of x0, we will get f of x1 minus f of x0. Similarly, the first forward difference at point f of x1 delta f of x1 equal to f of x2 minus f of x1. Okay, now the first forward difference at point f of x2. Okay, so delta f of x2 equal to f of x3 minus f of x2. Okay, so f of x3 minus f of x2. Similarly, for the last point, first forward difference at delta f of x3. Okay, at point f of x3, you will get f of x4 minus f of x3. Okay, so if we have the first forward difference, we can calculate the second forward difference. So second forward difference is denoted by del 2 f of x. Okay, so if we apply the second forward difference at f of x0, then we will get del 2 f of x naught is obtained by equal to del f of x1 minus del of f of x naught. Okay, so if you subtract delta f of x1 minus delta f of x naught, then you will get del 2 f of x naught. So f of del 2 f of x naught equal to f of x2 minus f of x naught, because f of x1 cancel here. Okay, so this is equal to f of x2 minus f of x naught. So similarly we can calculate the second forward difference at point f of x1. So we will get delta f of x2 minus delta f of x1. Okay, so delta f of x2 minus delta f of x1 will get f of x3 minus f of x1, because f of x2 and f of x2 cancel here. So this is equal to f of x3 minus f of x1. Now we can calculate del 2 f of x2. So del 2 f of x2 equal to del f of x3 minus del f of x2. Okay, so del f of x3 minus del f of x2. If you subtract these 2 points, then you will get f of x4 minus f of x2. So f of x4 minus f of x2. Now we have second forward difference. You can calculate the third forward difference, del 2 f of x, del cube f of x. Now if you apply the third forward difference at these two at point f of x naught, then del cube f of x naught is obtained by subtracting del 2 f of x1 minus del 2 f of x naught. Okay, so if you subtract these 2 points, then you will get f of x3 minus f of x naught. Okay, next we can calculate del cube f of x1. Okay, so this is obtained by subtracting these 2 points. Okay, so del 2 f of x2 minus del 2 f of x1. So this is equal to f of x4 minus f of x1. So if we have the third forward difference, we can calculate the fourth forward difference, del 4 f of x. So del 4 f of x is obtained by subtracting del cube f of x1 and del cube f of x naught. If you subtract these 2 points, then you will get del 4 f of x naught. So del 4 f of x naught equal to, if you subtract these 2 points, then you will get f4 minus f of x naught. Okay, f4 minus f of x naught. Okay, so this is your forward difference table for any given data set. Okay, now for example, let us consider one example. So suppose we have data set x and fx. So how to construct the forward difference table for this data set 4, 6, 8 and 10, and we have function value 1, 3, 8 and 20. So first we will write these data points in the column form. So this is our x, this is your fx. So 4, 6, 3, 8, 1, 3, 8 and 20. So first forward difference, delta f of x is obtained for f of x naught. It is obtained by subtracting these 2 points. So we will get 3 minus 1 equal to 2. Okay, so for next point, it is obtained by subtracting these 2 points. 8 minus 3 is equal to 5, and then for next point we will get 20 minus 8 equal to 12. Okay, so second forward difference, del 2 f of x is obtained by subtracting these 2 points. Okay, so 5 minus 2 is given 3, and 12 minus 5 is given 7. Okay, now we can calculate del cube f of x, which is obtained by subtracting these 2 points. 7 minus 3 equal to 4. Okay, so this is the forward difference table for this given data set. Okay, so this forward difference table is basically used when we calculate when we find the Newton Newton forward difference formula. Okay, so similarly we can if we have the given data set, so we can calculate the backward difference table also. Okay, so what is the backward difference table? Let us write. Suppose if we have data set like x and fx, so x is given x0, x1, x2, x3, x4. Okay, this is your f of x0, f of x1, f of x2, f of x3, f of x4. Okay, so first backward difference operator f of x is obtained. We can use so can we use the backward difference operator at this point? So no, because for backward difference operator we need the function value at previous point. Okay, so because before x0 we don't have any point, so we will not use the forward difference or backward difference operator at this point. So we can calculate the backward difference operator at this point. Okay, so what is backward difference operator? F of x1 equal to this obtained by subtracting these 2 points. Okay, so this is f of x1 minus f of x0. Okay, similarly the backward difference operator at x1 at x2 you will get f of x2 minus f of x1, and for these 2 points we will get backward difference operator f of x3 equal to f of x3 minus f of x2, and for this point backward difference operator f of x4 equal to f of x4 minus f of x3. Okay, so if we have first backward difference operator, we can calculate del 2 f of x. Okay, so del 2 f of x is obtained by subtracting these 2 points. So del 2 f of x1 equal to f of x2 minus f of x0. Okay, if you subtract these 2 points, you will get x1 cancel here, you will get f of x2 minus f of x0. Similarly, del 2 f of x2 is obtained by subtracting these 2 points, you will get f of x3 minus f of x1, and del 2 f of x3 equal to f of x4 minus f of x2. Okay, f of x4 minus f of x2. Okay, now we can calculate the third backward difference table f of x, del cube f of x. So it is obtained by subtracting these 2 points. So basically we will get f of x3 minus f of x0, and this is f of x4 minus f of x1. Okay, similarly we can calculate the fourth backward difference operator del 4 f of x, which is equal to, if you subtract these 2 points, you will get f of x4 minus f of x0. Okay, so similarly for the same table, this we can calculate the backward difference table also. Okay, so this is all about the difference operator and the relations and the forward and backward difference operator table. And so if you have any doubt, then you are free to write in the comment box. Okay, so thank you everyone for watching this video. Thank you.